Hi, today I'm going to go over measurements and conversions. All right, we have two types of measurements. We have qualitative and quantitative. So you can think of qualitative as observations and quantitative number and a unit. Let's show some examples. So I like to abbreviate them L for qualitative and N for quantitative. So today the temperature is 89.5 degrees. That measurement is quantitative. It is very hot today. That measurement is qualitative. And then this one is tricky because it has two. Quantitative, 600 milliliters, and tall is qualitative. And then the last one is a number, so it's quantitative. Long just tells me the direction. It's just the length. Both types of measurements are important. When I'm in the lab, I need to make both qualitative and quantitative measurements of my experiment. And what I want you to know is that no measurement is exact. All right, because humans made the instruments, and humans are always going to have a little bit of error when we read our measurements, when we take our measurements, when we build our instruments. So that brings me to two types of errors. We have random errors, errors that don't have a pattern to them, and then systematic errors, errors that do have a pattern to them. So an example of a systematic error would be an instrument calibration issue. So if a balance is off by 0.01 grams every time, then that would be a calibration issue, and I need to look at that. Random errors are like temperature, or most frequently in our classroom is air currents because the windows are open, vibrations, anything that is not going to be the same every time you do the experiment. So the air, the temperature, those are random errors. What we're going to do is use the SI system. It's based on the meter. It's a more modern version of the metric system. And there are 7 base units. So you don't have to have these memorized. I just wanted to show you that we're going to use meter for length instead of feet, kilogram for mass instead of pounds, seconds instead of like minutes, which we still use, right? We still use seconds, so that one's not too new. Kelvin instead of Celsius or Fahrenheit, and then mole is our big one. This one is very chemistry focused, so this one I'm super excited about. And then the other two you will use in physics or maybe later on in your scientific career. But these are the 5 that we will use in chemistry. Same with the prefixes. Hopefully these are a review to you. For the metric, P for pico, N for nano. This is the letter mu for micro, M, little m for milli, not to get confused with capital M for mega. C for centi, D for deci, and K for kilo. And then just wanted to remind you that in chemistry, we measure mass. I don't care about its weight because that's gravitational pull. So don't tell me it weighs 5 grams. It has a mass of 5 grams, okay? So let's do some problems. I realized that number 1 is a scientific notation problem, and I created this before I realized that there was not a good scientific calculator online. So when I convert, I always start with what I know. Okay, and the way I set this up is going to help you in the future of chemistry with something called stoichiometry. So I set it up in this chart like this, okay? So I need 2 things, a calculator and my conversion sheet. So I posted it in your folder, and I also posted it on the home page. So I'm going to look for PG to G on here. So picograms is on here. It says 1 gram equals 1 times 10 to the 12th picograms. So I'm going to put that over to the side here. And how I set my chart up is underneath what I am given, I'm always going to put a 1. And then what I'm going to do over on this side of the chart, on the right side, is turn this conversion factor into a fraction. And the way that I put know which one goes on the bottom is which unit matches with what I'm given, with what I start with, PG. 1 times 10 to the 12th PG, and then 1 gram would go on top. So you can think of this as one big fraction. So whenever I have something on the top that's the same on the bottom, they're going to cancel out. So that's my goal. Cancel out my original units, and I'm left with what I want. Okay, so I'm going to multiply across. So 5.45 times 10 to the 5th divided by, because times 1 is itself, 1 times 10 to the 12th times 1 is itself. Some fun, easy way to multiply and divide scientific notation. When you divide the coefficients and subtract the powers. When you multiply, you multiply the coefficients and add the powers. So 5.45 is itself, because it's divided by 1, times 10. 5 minus 12 is -7, and I want grams, because that's what's left. All right, so let's recap. I found my conversion on my conversion sheet. I started with what I knew, what I was given in my problem. I put it over 1, and then I turned my conversion factor into a fraction with the one that matches the units on the bottom and the one that has my new units on the top. Multiplied and then divided, and I got my answer. So let's look at this one. On my conversion sheet, I will find that 1 kilogram equals 2.20 pounds. LBS is pounds. So 79.8 LBS, or pounds, in my chart over 1. And then I'm going to turn this into my fraction. Which one am I going to put on the bottom, kg or LBS? Pounds, because it'll match on the diagonal. LBS, 1 kg. Multiply across, so I'm going to be left with 79.8, because 79.8 times 1 is itself, divided by 2.2 times 1, 2.20, equals, it's going to be equal to 36.27 repeating. But I just want you to give me as many numbers as I gave you. So just round your answer to 3 numbers. So that would be 36.3 kilograms. Okay, we could do the same thing with volume. For volume, I would find this on my metric unit conversion. 1 liter equals 1,000 milliliters. I find that on the back side or the second page. I start with what I know, 6.87 liters. Put it in my chart. 1. What's going to match? 1 liter. 1,000 milliliters on top. So 6.87 times 1,000 divided by 1. My liters cancel out. 6,870 milliliters. Okay. And then our last one, if I look at this on my front side, it's going to be 1 gallon. You could abbreviate it GAL, equals 3.785 liters. So I start with, let's just do 2.56. We'll take out the scientific notation. 2.56 liters over 1. And what's going to match? This one. 3.785 liters, 1 gallon. Okay, and my calculator gives me 0.676 with a bunch of other numbers, but I just need to have 3 numbers in my answer, round to 3 numbers. These are called significant figures. 676 gallons.